Today we're actually joined by Cameron Smith at TechLogix. Cameron, are you there?
Yep, I'm here.
Well, thanks, Cameron, for hopping on. I'll actually let you just jump in and get rolling.
Sounds good. Thanks, Chris, and thanks to everybody at Capital for inviting me here today. I'm very happy to do this fiber training. Anybody who follows TechLogix, you know we do a lot of training. This is a pretty important area for us. We've been doing CEDIA trainings for several years now. Good news is, if you're coming to this for renewal units, you get renewal units for this webinar. You know, often folks have to take these workshops live, and we do offer this as a workshop live. There's certain things we can't cover today in the session because it requires some hands-on, but we'll make sure you get the links to watch some videos, keep your learning moving forward. If you're coming at this session looking for Bixby credit, this course also counts for that. And on the screen, you see the different course codes. Feel free to contact us afterwards. You'll see some contact information. We can get you the information for those renewal units. As Chris mentioned, we love questions. Feel free to type those into the GoToWebinar widget. You are muted, so it does no good talking at the computer this morning. You will also receive a recording of this session. So, you know, depending on what you're doing, if you want to share this with other folks, if you, want to go back and review things, you will get this recording, and feel free to ask for the slides. We're happy to share those. Without further ado, let's start talking about fiber. And as I mentioned, this is a course that we've offered for quite some time. It is a CEDIA course. We're not going to give you a shameless product pitch this morning. We're going to make sure that you know why fiber is incorporated into more and more AV projects. We're going to talk a lot about the technology and how you put that technology together to make a system operate, how to make sure that system operates effectively and efficiently right out of the gate and for years to come. And we'll make sure you're picking the right products. But I always like to start with the future of AV, fiber optics. Why are we doing this? And if you've been in AV for any time, you know that we've seen this progression from twisted pair, copper-based systems, extenders, and now all of a sudden over the last 12 to 18 months, there's all this conversation about fiber. Why is that? When we started teaching this course, people would come, they were curious, they knew that, one day fiber was going to be affecting the installations and they'd have to incorporate it more and more, but it was really an if conversation, right? Well, today you have to do it. I mean, the consumer technology that we are operating with in today's custom and professional environment, it really requires us to use optical cable. And certainly if we talk about how do I future-proof my installation, how do I make sure my customer can plug their devices in for years to come, we have to talk about fiber optic cabling. And here's the good news. If you're completely new to this topic, and I will tell you that lots and lots of people who take these courses, they are completely new to this topic, the fiber ecosystem, the parts and the pieces that we use every day, it's really not that much different than the twisted pair ecosystem, the products you've been using for years to make your AV systems work. What do I mean by that? Well, let's look at those parts and pieces, okay? Most people think about fiber, they think about bulk cable, right? They think I'm going to have a cable running to the house and wire the DMARC, or maybe I'm going to wire up this office building and make sure I've got fast speeds for webinars and video conferencing and things like that. Well, people think of bulk cable and they think, okay, I'm going to terminate that bulk cable. And absolutely, that is a central part of the conversation. And that bulk cable today can be manufactured in different ways. We may armor it. We may bury it. We build cables in different ways. And the fiber that goes into those cables can be glass, it can be polymer, it can be polymer coated glass. There's different ways we will construct the cables. Okay, that's a big part of the conversation. And yes, you will terminate those in the field. And yes, you will buy tools and you will test the cables, and this is all part of that conversation. But where fiber really starts to depart from that traditional twisted pair conversation, or really any low voltage, traditionally copper-based cable conversation, is in the pre-mades. Whether we call those patch cords or pre-terminated cables, call them what you will, but fiber's a little different than traditional cables that we've used in the past. Okay, what do I mean by that? Well, when we think about patch cords or pre-terminated cables, we usually think about rack interconnects, right? I've got two different boxes that are wired into this rack. I'm going to connect these with a couple of different cables. It's usually a short cable run. That's what we tend to do. Well, in the fiber world, it's incredibly common to buy a pre-terminated cable that really comes in any length, any configuration. And when I say any length, I literally mean, hey, you've got that gate application where you've got a security camera 2,000 feet away, 3,000 feet away, 2 miles away. Fiber is an incredibly strong, surprisingly strong, very small, pliable cable. Okay, the technology's come a long way, and you can buy a pre-terminated cable that's plug and play that you pull over that distance. And a factory, a machine will build that cable, will put the connectors on, will wrap that cable so you have a secure way to pull it up to 100 pounds of pull rating strength. So these things are strong. But here's a really surprising thing. Pre-terminated cables often cost less than terminating in the field. And it has nothing to do with labor. It has everything to do with the parts and the pieces, the actual fiber cabling, the type of connectors. When these are machined in a factory, pre-mades are built in a factory, it often costs less for those components than what you would use hands-on in the field. So as integrators start their fiber journey, they often think about pre-terminated cables. They will often start by measuring the distance, buying a cable that's pre-terminated, simply pulling it and plugging it in. In fact, we offer online courses that just walk you through how to do this, how to design a cable, what to look for, what to look out for, things like that. So think about pre-terms, think about pre-made. It's a very good way to start your journey. Now, of course, we have cable, got to mount it somehow, you got to secure it. There are also enclosures, right? Wall boxes, rack trays, wall plates, things like that. But here's where the fiber conversation really starts to get interesting. The electronics. These are the game changers. So when I teach this course for CEDIA, every year, teach this course live, get a big workshop, lots of people sitting in a room, going through this session. Undoubtedly, there will be somebody in the course who says, hey, Cameron, look, I installed fiber 10 years ago. Never used it. Wired up this house, wired up this building, never used it. Why is this any different today? Well, look, fiber is not a new thing. Okay, it might be new to you, might be new to the AV industry, but fiber's been around for 50 years, okay? We've been integrating optical cable for a very long time. Here's the thing. We never really needed it for the bandwidth. We never really needed it for a lot of the different properties that we're seeing affect the installation today, the AV installation. We'll talk through this here in a minute. But what's really important for AV is there really wasn't a lot to plug into your fiber. There weren't little black boxes that actually let you use it effectively for things like HDMI or network switchers with fiber ports. It wasn't a thing that was really prevalent in AV installations. That's changed. We have black boxes now. We have to think about what type of devices I'm going to be plugging in, because here's the deal. The signal bandwidth that we're working with today, the resolution, the size of these video signals, you have to use fiber. We're going to talk through this, right? And I'm sure that you have done an AV installation before. You are familiar with the evolution of video in our industry, right? We've gone from 720p, and actually even before that, 480i, 480p, kind of that standard definition video to 720p to 1080p. And now we talk about 4K, okay? We have 4K. And 4K is a very interesting standard. So, depending on your history in the industry, that, when we used to talk about 480i or 720p or 1080p, it's pretty easy, right? Here's my spec, here's my HDMI chips on the inside. Easy. Devices, they're fairly straightforward in terms of bandwidth and, the aspect ratios and things like that. Well, modern 4K has a lot of moving parts, and 4K is being installed in most installations. When you go out to buy a flat panel, odds are it's going to be a 4K flat panel. It used to be 1080p, now it's 4K. It's becoming the standard. And depending on what you're doing with that 4K stream, it can either be above 10 gig or below 10 gig. 10 gig is really the magic number. So some manufacturers, what do we call this? 18 gig 4K, maybe 4K 6444, maybe HDR enabled 4K. Depends on who you talk to. But the punchline is any signal over 10 gig is exceeding the max capacity of twisted pair. Cat 6, Cat 7 even, these cables max out at 10 gig. So if you have a 4K signal that has HDR enabled, or maybe a 444 color space, or maybe 60 frames per second, you're exceeding the max capacity of twisted pair. The cable can't handle it natively. So here's the thing. I know you're thinking right now, wait a minute. I just bought some twisted pair extenders, HD-based extenders. Pretty darn sure I sent 4K through those things. What gives? You're telling me I can't do that. And the answer is, yeah, you can do that. You can send 4K over twisted pair, but not natively. You gotta compress the signal. You gotta take the 444, the color space, you gotta compress it down to 420, get your 18 gig signal down to about 9 gig, transmit it, then blow it back up. It's possible. Not ideal, but possible. Often what you'll see is some color banding, some artifacts, a little bit of latency on the processing, but it is possible. But now we have an issue. Here comes 8K. And 8K, just like 4K, has a lot of moving parts. Big topic of conversation. And I can tell you that the whole 8K conversations was driving a lot of folks to taking these CEDIA and BIXI fiber trainings. 8K goes up to 48 gig. 48 gig, much too large to compress effectively down below 10 gig, okay? We're dealing with 200 and 300 to 1 compression algorithms. You completely destroy the integrity of the signal. Can't do it effectively. You have to think in terms of optical cables, okay? Now, if we were sitting in the room, guaranteed hands would be going up right now because people would say, well, wait a minute, time out. This isn't quite so straightforward, right? And I will tell you that 6 months ago, even a year ago, there weren't a lot of 8K displays. You just didn't see it, okay? And again, we've been teaching this course for several years now. The 8K conversation was very hypothetical. Today, you can go out, you can get an 8K display pretty darn affordably. And whether you're watching this webinar live today, it's April 2020, or maybe you're watching it recorded, we have seen the prices of 8K displays and projectors come down quite a bit. These are readily available on the market. And just like any other consumer technology, you will see the prices continue to decrease. That's what our industry does. So there are peripherals. You can watch 8K displays and projectors readily available, right? But what about content? This is where it gets a little bit tricky, okay? What about 8K content? Because I'm willing to bet most people who have had any experience with 8K, your displays, your projectors, they probably had scaling algorithms, right? They took 1080p, maybe 4K content, they scaled it up. What about content? Well, here's where the conversation gets interesting because most people don't realize there is 8K content out there. In fact, there's a lot of 8K content out there. TV shows, movies, sports are arguably the best example of this. Sports. If you've ever watched instant replay, you're seeing content filmed in 8K. We've been filming content in 8K in ultra high definition resolutions for quite some time. Okay, that's how we do Zooms. If you look at the ball on the goal line, if you look at, the batter's box, the zoom, the instant replay zoom, that is complements of filming in 8K. Now the problem is It gets sampled down in post-production, right? We don't take that native 8K content. We don't stream it to the home. It doesn't happen. It's too big. And frankly, up until recently, there hasn't been a lot of 8K displays or projectors that would even accept that content. There is content, but it hasn't found a way into distribution. As we know, thinking about what we saw with 1080p and 4K, that will change, right? That content will become more readily available. Anybody who's taken any other classes with TechLogix, you know we have one with our on esports. Yes, esports. You see native 4K, you see native 8K content. Video game industry, the professional video game industry, is one of the places that really pushes these resolutions very quickly, and one of the first players there. But we still got to look at how we get 8K to the house. And here's where 8K gets incredibly interesting. So we have content, might not be making it to the consumer yet. We have 8K displays and projectors. How do you put these things together? And 8K is the first broadcast standard that's not designed for traditional broadcast. This is why it's interesting, right? Think about your installation. We're seeing a shift in the industry right now, the professional AV industry, low voltage industry, moving away from set-top boxes to streaming media players. Okay? This is happening. Think about your installations. How many Apple TVs? How many Rokus? How many smart TVs are we seeing? We're seeing this trend really impact the installation. And 8K is really central to all of this. As we go to a more of distributed streaming content, the providers who historically provided set-top boxes, Charter, Spectrum, Comcast, DirecTV even, right, satellite providers, they're going to streaming protocols. Streaming protocols allow us to literally check a box, a software box, upgrade those streams from 1080p to 4K to 8K. Now, this is not an immediate thing happening tomorrow. The whole infrastructure has to gear up for this. We're seeing the bits and pieces of this come together right now because, frankly, it's less expensive for the telecoms to move in this direction. 8K peripherals, 8K content, 8K distribution to the home via streaming media. It's all in play. You're seeing it, bits and pieces of this impact your installation. But here's the reality. The reality is video distribution still has a way to go. Okay, we have to get HDMI 2.1 chips. We have to get all of these infrastructures wired up. Most fiber that's being deployed today is being used for core networking. And whether we use that network to stream 4K today, 1080p today, these networks have to handle very robust signal distribution. I'm a data guy, okay? I like statistics. I like to see trends in the industry. And one of the trends that I find incredibly telling, if we look at the amount of connected devices in the average middle-class consumer household in the United States, average, okay? Most of us on this webinar today, we don't tend to sell to average middle-class homes. We tend to sell and work with more affluent. But the average middle-class home in 2018 had 23 connected devices, okay? What used to be your phone, your tablet, maybe your PC, well, it's shifted. Those still connect to the network, but now we have security systems, appliances, wearables like watches, right? I've got kids. Half my kids' toys come Wi-Fi enabled for some reason. This year, 2020, that number is expected to eclipse over 50 devices per household. So as we talk about networks that have to be video ready, streaming all this content, we also have to think about all of the other devices hitting the network, all of this traffic that has to find its way from device to device, back to the DMARC, streaming content from not only the internal network, but also the external internet. We have to put it all together. We have to create a system that will handle this. Now, as I mentioned before, fiber's not new, right? It's been around for over 50 years. And if we think about this, well, I'm pretty sure 50 years ago, people weren't saying, hey, I better come up with an optical cable because I'm going to stream 8K eventually. So come on, let's think about this. No, the reality is there are other benefits to fiber. There are reasons we integrate this, and we have for quite some time, 5 decades. Fiber systems, they're completely immune to power issues like surges, static electricity, lightning. They're also immune to interference. So if you've ever had a twisted pair extender, right, locks up, maybe you install everything, works great, get a call 7 days later, no picture on or no image on my display, power cycle the thing, it works again. Well, that's caused from interference. Fiber's immune to that. No RF, no electrical interference, okay? It's a very stable, in fact, one of the most stable platforms for sending our signals. That's why we use it. That's why we've used it in medical, government, military, right? Mission critical networking applications, we use fiber. It's also great for long distances. So when we think about those applications, again, I'll go back to that gate camera where I'm 700 feet away from the house, 2,000 feet away from the house. Lo and behold, fiber can handle those distances. In fact, one of the biggest consumers of TechLogix technology, the electronics specifically, casinos. We can take for about $500 per set. These things aren't terribly expensive. We can take extenders that will take that 4K signal and literally drive it with 0 frame rate latency up to 6 miles over standard fiber. That's what it does. There's lasers. We're shooting lasers from point to point. Fiber goes very long distances. But none of this matters if you can't handle it, right? You can't terminate it, you can't install a system, and it's not affordable for you and your consumers, your customers, okay? That is arguably the biggest advancement of fiber in the last 2 to 3 years. This is incredibly deployable now. All right, most important slide, in my opinion, this entire deck, fiber versus twisted pair, because this, in my experience, is what surprises a lot of people, okay? They come to this session thinking, man, fiber is going to be breakable, really expensive, hard to handle. If I get some shards of glass in my skin, I'm going to die, right? It's usually not super positive, okay? Here's the reality. And we're still a little early in the training. So you might not understand what duplex means or single mode means or multi-mode. We'll get to that. But here's the punchline. What if I told you most common fiber that's being installed for commercial residential applications, duplex single mode fiber, okay? This is what we would call a pre-wiring cable. You can pull it indoors, outdoors. It can be fully submerged, right? It's waterproof. Plenum spaces, in-wall rated. By the way, this cable's fully future-proofing. Got 10,000 times more bandwidth capacity than Cat7. 4.4 millimeter bend radius, 30% smaller than Cat6, half the diameter of most shielded twisted pair. You can reliably terminate this in less than 2 minutes. By the way, it's got a 100-pound pull rating, right? We joke about I can tie this cable to the back of my truck and pull it through conduit. Well, guess what? You can actually do that with fiber, okay? It's super strong. And what if I told you that this cable that you can wrap around your finger, it won't break, costs 20 cents per foot. Universal cable, 20 cents per foot. Terminates faster than twisted pair, shielded twisted pair. Stronger, more pliable, and it future-proofs. 20 cents per foot trade price. That surprises people. This is where we've seen optical technology go. It is a far more robust experience for you. It is a far more reliable experience for your customers. This is why we're seeing the momentum in the fiber optic world. But you got to understand the cable, okay? If you've never seen a fiber optic cable before, you just look at the spool, Yeah, it made it look a little smaller than that traditional copper cable. Yep. But it's when you cut back the jacket, you get beyond that jacket, the plenum rated jacket, the riser, whatever we make with it. Maybe there's armor on it. You build these cables in different ways. But it's once you get past that jacket that you're dealing with fiber. And the most telling portion of the cable is actually the strengthening fiber. So if you ever cut open a fiber cable, you notice there's like yarn on the inside. That yarn, very fine, but it's very strong. Most of us manufacturers, we build that yarn out of Kevlar. The same materials that go into things like bulletproof vests, that goes into a fiber optic cable. This is why you have a pull rating over 100 pounds. And in fact, in some of these cables, pull rating up to 220 pounds. They are strong. That strengthening fiber that, trust me, you can't cut with the scissors. You can't cut with a knife. You got to use Kevlar shears. It really makes the cable strong. But once you get past that, get the yarn out of the way, now you get into where the optical properties happen, the heart of the cable. That's the core. And we build that core out of plastic or glass, what's known as bend-in sensitive glass, really durable and really pliable glass. And we wrap that glass or that polymer with a cladding that keeps the lasers inside the cable, and then an overall coating. And depending on how many different cores, pieces of glass we have in the cable, depending on how we jacket those cores, we build our cable in different configurations. And we don't talk. So this is, by the way, time out. It's a little counterintuitive, I know, for most people who've done copper-based installations, right? We don't talk about fiber in terms of conductors because we are conducting nothing. And that is the catch. There's always a catch. The catch with fiber is there is no conduction of electricity. We have to think about, how do you power your electronics? Both ends of the cable, you need power. And sometimes that power comes from the HDMI or USB port on the display. Sometimes it comes from your traditional AC feed, right, your outlet. But you got to think about power. How do I power my devices? And this is why we don't talk about fiber in terms of conductors. We talk about fiber in terms of strand count. And simplex fiber is the most basic of strand count. One strand equals simplex. Now, here's the thing. You can buy extenders, HDMI extenders, that use one strand of fiber, simplex fiber. We make them at TechLogix. Other manufacturers make them. A lot of people think fiber does not send signals bidirectionally. It only goes in one direction. And while, yes, it's common that you always need two strands, you can have bidirectional communication. We just shoot our waves at different frequencies, different wavelengths. And that's why simplex will send HDMI. You have a handshake, you have bidirectional communication. Here's my recommendation to you. You never pull simplex, ever. Even if you only need one strand for your video distribution, don't do it. And that is because it is not standard. In the industry, electronics manufacturing, standard is to have two strands at a minimum, duplex fiber. And that is because, as I just mentioned, most electronics use one strand to send and one strand to receive. It's actually less expensive when you build your electronics to do that. You have less processing, less optical engines. Less optical engines make the electronics less expensive. And if you've ever looked at the SSP port, the fiber port on a network switch, you'll notice it's got two connections. One side sends, one side receives. You need duplex fiber. So even if today you only need one piece of fiber, pull two. It'll future-proof your run. You will not regret it. Make sure as you are helping your customers wire their buildings, their homes, you pull two fibers. Now you can also get multi-strand. This is where you have more than two, right? You have 4 strands, 6 strands, 8 strands, 12, whatever the number may be. And we build those multi-strand cables and either breakout. That's where we're jacketing the internal strands quite heavily, making them very robust, makes for a bigger, thicker, less pliable cable, or we have micro distribution. That's where we have less jacketing on those internal strands. It makes for a much smaller cable. In fact, you can take a cable that's about the diameter of a pencil, and you can have up to 24 pieces of fiber in it, 24 strands. And I will tell you, this is the part of the training, whereas if we were sitting live together in a room, I would be walking around showing you this fiber, 24 strand fiber. And if you've never seen high density micro distribution before, you'd probably look a lot like most of the people in the room. In fact, you can read their expressions, right? They're looking at this cable, size, the diameter of a pencil, all these tiny little strands in it. And undoubtedly, you will see the guys who laugh and say, there's no way I can handle this, right? These tiny little strands, about the size of a human hair, right? How am I going to terminate this? How am I going to handle it? And this is why we have enclosures, okay? You need to make enclosures part of your installation, whether it's a rack tray or whether it's a wall box, okay? Fiber optic enclosures are made specifically for fiber optic cable. You don't want to use twisted pair enclosures or generic rack trays for your fiber installation. Why? They don't handle the strands, the little strands. You got to protect those. You got to break them out. You got to manage them. And you can always tell a fiber optic enclosure because it has a couple of components to it. It has a coiler, right, for service loops and to manage your excess fiber optic cable. It manages breaking open that jacket, unzipping it, taking those individual strands out, sending them into the individual couple points, the connectors, the splice points, right? This is what fiber optic equipment does. And whether you get a rack tray or a wall box, you can always tell it's for fiber because those strands are managed. Even demarc boxes, plastic outdoor demarc boxes, they will have these components built in so you can manage these strands. It's a very common part of the fiber optic conversation, and I encourage you, incorporate them into your design. They're really not that expensive. They start around $50 trade price. They'll make sure you have service loops, so extra fiber. If you're going to break fiber in the field, usually you're going to break it at the connector. That's where you're going to see the damage, and you have extra fiber to fix it. Or you have the fiber in the strands properly secured so those lasers fire properly. We'll talk about that here in a minute. My advice to you, make sure you get enclosures, make sure they become part of the design. Now, you also have to choose the right fiber. And there are two different types. And the good news is these are color-coded. You have single mode. That's the yellow cable. If you've ever been on a project and you've seen a yellow fiber optic cable, that's a single mode fiber. And then you have multi-mode. Depending on the grade, we'll get to that in a minute. Multi-mode can be aqua, could be violet, could be orange. Most modern cable that you're seeing integrated today, it's aqua. Multi-mode Ohm 3, very standard, okay? Here's the easiest way to think about the two different cables and their differences. Single mode is what we use for long distance applications. Now, yes, you can use single mode for short distance. In fact, in a lot of commercial projects, we just see single mode being used for everything. I want to go 1,000 feet, single mode. Want to go 1 foot, single mode. Want to go 5 miles, single mode. This is the cable that connects buildings, cities, continents. That's what single mode does. Multi-mode fiber, well, this is really good for rack wiring, shorter distances. And in the fiber word, shorter means 1,000 feet or less, okay? Now, this is a little counterintuitive, again, for folks who've done copper-based systems for years, okay? Because when we wire with copper, when we think about longer distances or maybe higher bandwidths, we think about putting more copper in it, thicker gauge. Fiber is the opposite. So that yellow cable, that single mode fiber optic cable that goes really long distances, this actually is a smaller core size. This has a 9-micron core, tiny little core size. It keeps those lasers in phase. Think about the physics here. If you're shooting an optical wave, a laser, a smaller pipe will keep your signals in phase longer distances. A thicker pipe, a bigger pipe like multi-mode, the aquacolor cable, 50 micron core, yeah, it can send more simultaneous waves, but they start to get sloppy. And that occurs at about 1,000 feet. And this is why you see single mode being integrated in a lot of applications. In fact, single mode actually costs less usually than multi-mode. It's a very universal cable for a lot of different environments. Now, multi-mode has a purpose. You can send more simultaneous waves through it. You can handle different frequencies very, very well. But really, I tell folks, think of two things. If you're doing a retrofit, stick with whatever cable's been installed. If you're exceeding 1,000 feet, never pull multi-mode. Don't do it. Go to single mode. Last piece of advice is we're on this topic. The two don't splice together natively. Two different core sizes, 9 micron, 50 micron. You gotta stick with one type of cable. They will not butt together effectively very well. In fact, not at all. You can't splice them together. Now, these cables also come in different grades, and single mode is an easy one. Optical single mode, OS, comes in two different grades, OS1 and OS2, and it really speaks to the construction of the cable. The good news is most manufacturers, TechLogix included, we standardize on OS2. But if you go into a project where OS1 has been installed, well, good news. You can splice the two together, no problem. They're both 9 micron cables. Multi-mode is where we have an issue. So multi-mode, you're really seeing 5 different grades, OM1 through OM5. And OM1, this was one of the early versions of multi-mode. Well, this is a non-standard discontinue sized cable. It's 62.5 micron. And as you've heard me talking, modern multi-mode uses 50 micron sized glass. So OM1 does not splice to really anything else out there. It's a discontinued size of glass. If someone's trying to sell you OM1, they are clearly not your friend and you should run away. Okay? You don't want to install OM1. Now, OM2 is the right size. It's 50 micron. It will splice into modern optical cables. But here's the problem. It's not a very pure optical glass. And frankly, it's not optimized for lasers. Lasers are what we put in most electronics today. You really, at a bare minimum, want to be thinking about OM3 or OM4 cable. Now, timeout. A lot of people will ask, well, wait a minute, Cameron, timeout here. I thought I was future-proofing when I pulled Cat 6. So everybody told me, pull Cat 6, you'll future-proof, and lo and behold, can't even do 4K natively with it, okay? So shouldn't I just pull OM5 and be done with it? And the answer is, yeah, I love your enthusiasm, but the reality is OM5 is, going to support the same amount of bandwidth as OM3 and OM4. It just supports more wavelengths that really have no purpose in an AV installation. Pull OM3, pull OM4, pull OS2. If you pull those cables, you will save a little bit of money, and all 3 of those formats support up to 100 petagigs worth of data. That's 10,000 times more bandwidth than Cat 7 cable. And don't get me wrong, I'd love to take your money, right? But you don't need to go crazy here. OM3 is going to be your standard. OS2 is going to be your standard. OM4 is a great cable. In fact, we haven't seen a huge price delta between OM3 and OM4. So a lot of our pre-mades that we build, they're OM4 cables. That's what we're using. Okay, we're using OM4 glass in the cable construction. The electronics are really the weak link in this whole discussion. The electronics are what are holding us back. They don't have the processing speeds. They don't have the signaling rates that the cable can actually handle. So if you pull OM3, if you pull OM4, if you pull OS2, you will future-proof your installation. And we also have to terminate those cables, okay? And the connectors we see in AV installations, there's really 2. Now, while there's more fiber optic connectors out there, ST and MTRJ and FC, FJ, we really only see 2 in the AV installation, LC and SC style connections. Now, here's the good news. All these connectors have the same physics behind them, the same performance, the same bandwidth capacity, the same optical lens performance. One connector is not better than another connector. It really comes down to the size. Even the termination process, the tools we use to terminate, they're the same, okay? It's really the size of the connector. LC connectors, these are your small ones. LC, some people call it the little connector. Technically, it's a Lucent style connector. This is what you see on SFP modules, on network switches. Very tiny, right? We can fit more connections side by side. We can make our electronics smaller. The SC style connector, or subscriber connector, some people call it standard connector, is bigger. It's actually a little less expensive. There's not a Lucent patent involved in it. Because it's bigger, because it's less expensive, a lot of folks favor this one for DMARC wiring. This is what you see in the telecom industry quite a bit. Now, as I mentioned, if you can terminate one, you can terminate the other. The process is really the same. The tools are really the same. The performance of the two is really the same. Here's where you do see a little deviation. And this is the part of the session where normally we do some termination, right? Hands on, get your tools out. Let's actually put some connectors on some cable. Can't do that very easily with this webinar. But here's what I can tell you. You can watch videos online that'll take you through the termination process. They last anywhere from 3 to 5 minutes. You can get these from the TechLogix website. The connectors are reusable. This is an easy, straightforward topic. I encourage everybody, and you will get a link to these videos after this session. I encourage you to watch some of these. It'll take you through the topic. Very easy to get started with this. And reusable connectors will save you money. You can reuse them with confidence, knowing that you're not going to be tossing these as you're learning. Now, where you do see a difference is in the type of fiber cabling that you're using. So if you use a polymer cable, like an SSF type cable, the process is a little different versus a Corning style cable. And again, there's videos that walk you through the differences. One type of cable is not necessarily better than the other. There are pros and cons to each. Price, handling time, things like that. Do a little research. You can even read articles online that'll tell you the specific differences to look for in the different types of cables and connectors. All right, let's talk about some applications, and we'll get to the most important part of this whole session, which is making sure you can do this effectively. I always start with DMARC wiring, okay? This is where people get in trouble. Very common issue, common error. So first of all, I do recommend you wire DMARCs, okay? Even though the telecom provider's got to bring in the feed to the house, bring it into the building, as we all know, they are not the most aesthetically minded folks out there. They will wire that DMARC wherever it is the most convenient for them. Next to the doorbell, great, let's throw a box right there. You know, next to the doghouse in the backyard, sure, we'll put up a post, put a box out there. I always encourage the folks who are wiring the house, the building, you put in the DMARC. Usually if it's new construction, you're wiring the fiber, the cable, prior to the service connection anyway. You should wire the building. You should choose where that DMARC location is going to be. You should pull the cable that's going to be the best path of least resistance, right? But here's what you have to keep in mind. Yes, while the DMARC is universal, the parts and pieces we use, the splices, the couplers, they're all universal. You got to make sure you pull the right cable. And if you think back to our conversation between single mode and multi-mode, you'll remember. Single mode cable is that long distance cable. This is the one that goes long distances. This is the one that we connect buildings, cities, continents together with, right? Yes, that DMARC, that's a long distance connection. That has to have single mode fiber. You have to pull single mode to the DMARC box. And frankly, anything before the modem needs to be single mode fiber. Far too often, we will see folks wire up a building and think fiber is fiber. I'm just going to pull my multi-mode, my aqua-colored cable there. It'll be fine. No, it won't. You have to pull the right type of fiber, pull single mode to the DMARC. Now, once you get past that modem, you can pull whatever you want, okay? stick to the distances, stick to one type of cable. Remember, they don't splice well together if they're different core sizes, okay? Now, one of the most common products that we see integrated with fiber is our friendly media converter. This will be your best friend, okay? Because here's the reality. Even though we're seeing more and more fiber, the problem is most of the fiber out there, it's either being left dark or it's being integrated with a device that doesn't have a fiber port on it, right? Think about your security camera. Think about your access point. Think about your PC, right? Think about all these different network-based devices, even things like AV over IP extenders, HDMI over IP extenders. You got RJ45 ports. How do I work with fiber? Well, that's where the media converter comes in. These are very low cost. I mean, we're talking trade price of about 65 bucks. They take an electrical signal like a twisted pair connection and convert it to an optical signal like a fiber connection. Flip it vice versa. This allows you to integrate those twisted pair devices onto a fiber optic infrastructure and take advantage of the things like immunity to interference, signal distribution length. You can take your security camera that has a twisted pair port out at that gate that would normally be limited to 100 meters or 330 feet of max distance. And the media converter will let you take that same camera and extend it up to 12 miles with 0 frame rate latency. That's what a media converter does. These will be your best friend. And the reality, as much as I'd love to tell you, you're going to see fiber ports on everything this year, next year. It's not the case. We know that's not the case. You will still need to integrate electronics that are twisted pair based into that fiber optic infrastructure for some time to come. AV over fiber, you are seeing more and more extenders that are fiber based. The thing that I want to point out here is these are designed to handle that video bandwidth. They're designed to exceed the 10 gigabit performance where twisted pair cables would normally max out. If you take nothing else away, think about these look just like HD-based T extenders, right? You've seen a twisted pair extender. What do they have? Video ports, audio ports, control ports like IR and RS-232. Man, these look just like the twisted pair extender you've been using for years. They just support more bandwidth. Use these. Why put in a $20,000 projector, a $100,000, high-end theater if you're going to compress your signals? Use fiber extenders. They're not that expensive anymore, right? These things start around $400 a set. Prices have come down. You can even do things like USB over fiber, especially now in this environment, right? We're doing a lot more webinars. We're doing a lot more distance learning, distance communication. We're incorporating high speed, super speed video through the computer over USB. Well, you're limited to 5 meters or 16.5 feet. That's the USB standard. USB over fiber extenders, they extend that distance. Really easy to use, plug and play devices. These will also be very useful for your designs. All right, start thinking about those questions. We got another 5 minutes worth of content. This is the most important thing though in this whole conversation. This is the topic of a link budget, okay? Very important. And frankly, not well understood even by folks who've been doing fiber for years. But this will make sure that you can design a system, install a system, have it work. Let's talk about the link budget. The link budget is comprised of two things: a loss budget and a power budget. The loss budget, you're familiar with this concept, trust me, right? Any cable run you do, you can look at that run and you can calculate, estimate how much loss you're going to have. How many splice points do you have? How many patch panels? What are you doing with that cable run? You can estimate the amount of loss based on what the cable path is and how it runs. We compare that to the power budget. Well, that's how much loss our electronics can tolerate before they don't work anymore. So if we take the anticipated amount of loss, the amount of loss we can tolerate, put those two things together, that is our link budget. And the reason I say that this is not really well understood, even by folks who do fiber and have done for years, is because what are they using their fiber for? Well, they're using it for networking. That's the predominant use for fiber today. And in the networking world, what happens if you have loss, packet loss, intermittent connection? Well, your system probably still works. It just runs slower. And frankly, you can be pretty okay at what you do. You can kind of hack those connectors onto the cable and they'll still have signal. It'll just run slower. And your customer might not notice a slower internet speed, but guaranteed they will notice if when they watch TV, do a webinar, the screen flickers in and out. Every 10 seconds, they get a black screen. Every 3 seconds, they get a black screen. They'll notice that. They might not notice slower network speeds, but they'll notice intermittent video. Video is not very tolerant to loss. And we have a power budget of anywhere from 3 to 5 dB in a video distribution application. So where does this loss come from? Well, not really the cable itself. Fiber optic cable, it is built incredibly well. Very high quality glass and polymers today. It's the splice points, the couplers, the patch panels, the connectors. That is where our loss comes from. So if we look at a real world application, and yes, I use a residential application here, but if you do commercial, superimpose this room into a house of worship, a church, a meeting room, right? Corporate meeting room, a classroom. Application is the same. We're taking video from a source device, the head end, and moving it out to a projector. In this application, we're taking a bulk cable, we're running it over to a wall plate, we're jumpering out of that wall plate into a remote receiver at a projector. We can look at this installation, we can budget, calculate a certain amount of loss. Our loss budget's about 1.3 dB. And we know, since we're doing video distribution, that we have a power budget of 3 dB. This system should work, right? No problem, should work fine. It's when we get out our handy little meters and we test the cable run, we find out that, wait a minute, lo and behold, our calculated loss is at 5 dB, 6 dB, 10 dB. Wait a minute, I thought I should be at 1.3 dB, what gives? This is when we get out handy tool from our toolkit. Comes with most termination kits, a VFL, a visual fault locator. This will test your connectors. This will test your cable. This will make sure things are operational. But I can tell you that, yes, once you test your connectors, you verify everything's proper, often you still will have higher than anticipated loss. Why? Well, think about it. We're dealing with lasers, light. We're dealing with waves of light going through an optical lens. And if there's anything blocking that from happening, we will have loss. We'll have disruption of those lasers. And in the networking world, it leads to packet loss, lower speeds. In the video world, catastrophic failures, right? Loss of video. It is incredibly important to keep dust caps in place as long as possible. Anything fiber optic comes with dust caps. Cables, couplers, connectors, SFP modules for your networking equipment. It all comes with dust caps. But here's the reality. We don't work in clean rooms. We work on ladders and crawl spaces. There's pollen in the air. There's drywall dust in the air. There's oil on our fingers. There's barbecue sauce from lunch. There are all kinds of contaminants that get into our connectors, onto our optical lenses, disrupt these signals. And for that reason, the one thing that I advise everybody, the one tool you can buy to make your life much, much better, buy a pen style cleaner, a click cleaner. These are like $65. They clean those optical lenses. And it's simple. I mean, you take the cleaner, you pop it into the port, you click it, puff of air, wipe of the lens, done. For $65, you can clean 800 to 1,000 lenses. Make the investment. It will save you hours in the field of troubleshooting. It is incredibly important. Final thing, I know we went through a lot in the last 60 minutes or 55 minutes technically. Make sure that you identify what type of fiber you're using. Modern fiber optic cables, these have bend-insensitive glass. These have polymer inside of them. They're really durable, really, really strong. But if you're going into a retrofit and there's cable that's already been installed, you have to assume that it's a little brittle. You have to assume that the bend radius is going to be over an inch, okay? You got to be careful with it, because the worst thing that can happen isn't that you break the cable. If that happens, you know it's broken. The worst thing that can happen is you damage the cable, because what tends to happen with fiber is if you damage it, get a crack in it, that crack gradually spreads over time. It will degrade, fall apart, and it takes a long time for that to happen. And your customer will see their performance fall apart. It's incredibly hard to troubleshoot. Handle those cables carefully. All right. Any more information's up on the screen. I'm happy to take a couple of questions. We have a couple of minutes here. I do see that we had a question about the recording, and absolutely, yes, this is recorded. Everyone will get a link to this. You will get a slide deck if you want it. You just email us the information. You see the links on the screen right here with our contact information. There's a lot of good resources available for you. Termination videos, more training modules. We encourage that. You will get an email after this session. And then I see one other question here. Can we convert coax, DirecTV to fiber optic? And while TechLogix doesn't do it, yes, there are products that are on the market that will let you work with different types of fiber infrastructures, different types of electronics out there. There's a whole world of solutions. TechLogix tends to focus on more of your core AV in the building distribution when it comes to electronics, wiring for everything. I mean, we do wiring for everything. Feel free to reach out. All right, a couple other questions that are coming in. We have a safety note, never look at the end of a cable. You are absolutely correct. That's actually a really good safety note. We always do this when we do live hands-on termination training. You never look at the end of the cable. The light that comes out of network switches, it is not visible, and it will damage your eyes. Ironically, the VFL, where it's a red light spectrum and you see it, it won't hurt your eyes as much as the invisible stuff. You never look at the end of fiber optic equipment. Does Capital carry everything shown in the slides? Absolutely. You can get everything from TechLogix through Capital. You can even get custom cables. So if we go back to that pre-terminated conversation, you can have the folks at Capital build you a pre-terminated, fully customized cable. Do we see the cost of multi-mode and single-mode network equipment getting closer in price? It's actually gotten very close in price. I mean, we see the SFP modules really deviate, depending on the model, by about $6. Prices are coming down on all fiber-based equipment. You'll see that continuing to happen. We have a question here on meters. How much information do we get from test equipment? Can you get the break location? Do you get the signal loss? And the answer is, yeah, there's a lot of different test equipment on the market, different feature sets. You can get testers from TechLogix that will allow you to meter the cable. It'll give you actually a loss reading. There are other solutions out there from, other companies like Fluke that will actually tell you where the break is in the cable. You have options there. Let's see here. So we've got a couple of other kind of design questions. We'll take those offline. Here's a question on how long does it take to get a custom pre-terminated cable. It usually takes anywhere from 3 to 5 days. That tends to be pretty standard. Plan an extra 3 to 5 days, but you got to make sure that those cables set up properly, and then you also want them to get certified for performance. So 3 to 5 days is pretty good. And do you need attenuators on a short run of single mode fiber optic cable? Another good question, and it has everything to do with the electronics that you're plugging in. Look at the spec sheets. Ask the manufacturers what they recommend. It's really a cable by cable, electronics by electronics conversation. Most AV systems do not need any attenuation inserted into the application. that's the main group of questions that we see come in. If there's anything else that might come up, feel free to reach out to us. Again, you see the contact information on the screen. I want to thank our friends at Capital for making this possible. If certification is important to you, you can certainly get industry credit for this. You can reach out to us with more information on that. I hope this was useful. I hope this was valuable. We're here to help you as you continue your fiber journey. I hope everybody has an excellent rest of their day. Take care. Be well.